Now we can talk about the treatment of drinking water, which is going to be a little bit different, but kind of the same concepts that we're using for sewage treatment. The only thing is, with drinking water, we're probably starting off with something that's a lot better than we did with sewage water. So one of the things we like to do is to clarify that water. Make it clear. Most people don't like drinking water that looks like what we see this person in this image drinking. And we definitely want to get rid of pathogens. One of the things that happened with cryptosporidium was the water treatment plant at in Milwaukee got contaminated with cryptosporidium, and they ended up pumping pathogens into a fairly large portion of the Milwaukee population. Not a very good thing. And then there is improving taste, and that could be a matter of removing metals and that sort of things that are soluble in the water that give it an off taste, that sort of thing. Throw in this little map here that shows you where we have good water coverage. Uh, in other words, where we have improved drinking water. We certainly have it here in North America. We have it in Russia, various other parts. It's not until you get here into Africa and some other regions where the fair amount of the population actually doesn't have access to uh, very good water. They get it from wells that may or may not have contamination. They don't have any way of purifying it. And there's a focus of a lot of humanitarian groups in Africa in trying to improve that situation. So one of the steps that we use to clarify it is called coagulation and flocculation. And basically what's happening is something is going to be added to the water that's going to get hold of any material in there that's organic or even inorganic, and it's going to cause it to precipitate. So it's going to form these larger particles that they happen to call flocks. And these flocks can get big enough then that they're going to settle out. And they're trying to represent that with this image here. You have these various things floating around in the water, and then something is added to it that causes these to bunch up and form the flocks. Uh, so then, so here they're showing you the water. They'll add the coagulant using rapid mixing because you want to get it all, suspended all throughout the water. And then that moves into another tank where the mixing is slowed down. At this point in time, they're not trying to agitate it so much. Just keep things moving a little bit so that the coagulant and the material within the water can form those flocks, and then that can be brought into another tank where the sludge settles to the bottom, and then the liquid on top, the water that's had a lot of this material removed, can then be pumped out and go into the next stage. And again, with the sludge, things can be done with that as well. With drinking water, there's usually a filtration step. Sand can be used, or diatomaceous earth, which is basically diatoms, which are these microscopic creatures that have silica in their outer cell wall, so to speak. And they're really good at getting fine particles out of the water. And so with the sand, oftentimes they'll start with a coarse sand and then work their way down to a finer sand. Sand not being soluble in water does help to remove stuff from the water. And you can use either one of these to get rid of a lot of the microbes. It can be protozoa, bacteria, and they're going to end up getting trapped within this matrix as the water goes through. And so the water at the very end is going to be pretty much free of these protozoa and bacteria. But just to make sure, the last treatment, or the last step in this, is going to be a chlorination. They treat it at a certain level that's going to kill the pathogens and other any microbes that are in there, so that the water that we get in through our tap should be microorganism free. Same thing for your bottled water. So in summary, with the drinking water treatment, we clarify first, and that's done with that coagulation and flocculation. Then we go through a filtration step. I said sand filters, or it could be diatomaceous earth. It can be done in tanks this size. It can be done in smaller tanks, larger tanks. It's just going to depend on the volume of water that has to be dealt with. And then they'll go through a chlorination. Now, some places will also use UV light when just before they're discharging the water. The treatment plant at Lane uses a UV light as its final step before the water is discharged, but that's wastewater treatment there. It's not water for drinking, but you can sterilize drinking water using UV light.